As we said in the introduction, the corporate password is something that people should only use within URLs of the corporation, but that's not what happened. I mean, customers go into these social sites and use the same password because it's hard to remember. So let me deal with it only once. And then when the database of passwords, hash or unhash or whatever, if the security of any of these sites is not good and they take those that database, they can easily figure out what the corporate password. If they see the email address in there, they may go to the company and damage is completely done. So we're going to show, and also another attack is that phishing. You get sent to a site that looks awfully similar in the URL to what you think it is a corporate site, and when in reality it is not. Or the HTTP link looks exactly as a corporate one, but it renders into a different URL, and you get phished. You put your corporate credentials, bang, I got the single keys to the kingdom, particularly in companies that implement single sign-on, in which one password opens all the applications of the corporation. So we're going to show in this example how the good guy, the unprotected good guy, gets phished, and then his password gets compromised. And we're going to show the same thing with the good guy protected by Apex, and we'll see that that doesn't happen. That his credential, he's actually alerted that his credential, his corporate password cannot be used in that way. So let's see that in action. We have here the good guy unprotected and the good guy protected with Apex right here. So let's open IE, and let's say that the guy goes to a website called CRM, this one, crmdemo.enterprise.com, which is a perfectly valid and legit corporate site. Goes into that site and puts his credential. He logs in, employee 100, and his password is my secret pass 1. And he logs in, no problem. You can see the data. But if he gets phished and he goes into a site that looks similar, but it's not the same, and this actually create this site for that purpose, and he puts the same credential, obviously his credentials are going. Employee 100, my secret pass 1, and bang, his credentials are taken. Now, what happens if we do the same thing with the guy protected with Apex? Well, let's launch IE and do exactly as I said before many times. This is the very same image as the other one, except that this has Trusteer installed. And let's go to that corporate site as well. And here we are. If we put the password, we'll see that we will log in as before. No need to actually show that. But if I go into the phishing site and we put the credentials, we can put employee 100, and then we put the password, my secret pass 1. Bang, we get Trusteer saying, no, my friend, I got a hash. This gave me the same value of this password in here. That's a corporate password. You do not put that in there. And in fact, it doesn't have to be just phishing site. Let's say that you go into another external site, salesforce.com, for example. Oops, salesforce.com, and you are gonna try to log in with the very same corporate password or create an account. Whenever you will see a password field that you're trying to inject, that is going to stop you. So here will be another username, and here the password is again my secret pass 1. Bang, you get the same alert. I mean, it's to say, well, no, corporate credentials should only be used within the corporation. So Trusteer protects the user from releasing his corporate credentials. In this second example, we're going to see how we're going to actually install a keylogger on the machine, both a good guy and bad guy, as we've done before. And we're going to show how that keylogger is actually obviously going to grab the user ID and password that the user is actually putting into a corporate site. However, we're going to see that when we do the same attack with the good guy that is running Apex, we see that keylog driver, keyboard driver that I mentioned at the introductory whiteboard, is actually going to tokenize the inputs of the keyboard, and will only detokenize them when the right application is the one that has the focus, the one that is the one that has the focus is the one that does the detokenation. And because the keylogger is on the background, it will not see the real password, but the one that has actually been changed. So let's see that in action. The good guy unprotected, we launch this program that is checking for leaks, actually acts as a keylogger, and we actually indicate that we want to get the keyboard state, and because we are not clicking on anything, we're not keying any key, we don't see any activity. So we're going to go to the same CRN demo site that we went before, and we're going to see that when we type the credentials, employee, we see that in the keylogger is really grabbing everything we type in here. If we put that password, the keylogger gets my secret password 1. So that's been actually compromised. Let's do the same thing on the good guy. So we're going to launch the same keylogger again. These two images are exactly the same, except for the fact that one has Apex and the other one doesn't. So we run that keylogger, and notice that here Apex, this green thing, is really running. So we click here to get the keyboard state. We launch IE, but again this works with IE, Firefox, and Chrome. So we go to the same site, CRM demo, and when we start typing credentials, notice that the keyboard is tokenizing all those things. I put employee 100, and that's not what the bad guy with the keylogger is seeing. If I put my secret pass 1, which is the one that is going to successfully log me in, notice that was a password because I was able to log in, but the keylogger doesn't get to see any of that. That's yet another way that Apex can protect corporate users from releasing their corporate credentials.